Good day, everyone. My name is Heather Downing. Thanks for joining me today. And let's start off by saying what we're going to talk about, okay? Something that kept me up a lot at night, especially since I spent so long in the security space, is how to handle the situation. Lots of people have run into this. I'm sure several of you already have. The reason why the title of the talk is AI Agents Need Permission Slips, it's because it's kind of like those permission slips we needed for school trips. I'm sure several of you in the UK had something similar growing up. And this was the best way for me to think about the problem. So the stakes this time, of course, are a little bit higher than going to the local zoo. But I figured this is the best way to approach it. How many of you actually have tried deploying agents in production for your company? A few of you. Well, you probably already know all of these pains and grievances. So the best thing that I want you to walk away with today is before you give an agent any permission, and I mean any permission at all, you need to stop and ask yourself one of the questions here. What is the absolute worst thing that can happen if this goes wrong? And then, which is the critical part, you need to actually design the system to handle the worst case scenario and be flexible about that, and not hope that it's just not going to happen. You can't rely on it just to be getting better in general, and just architect for failure. Yes? I'm sure if you talk to each other during our break in the evening, you'll find lots of wisdom with the failures that have come from here. But if you architect for it in the first place, you'll be in a much better place. All right. So I want to set clear expectations. This is a basic conversation between myself and you. This is not going to be some sort of vendor pitch, or I'm not going to sell you anything. This is just talking about how to think about this. This is methodology. And some of the things that I'll show you may not even exist in 2 years, and that is totally fine. What you should take away with is how to think about this problem. All right. So here's the roadmap for our conversation. First, we'll start with why this matters. And I'm going to show you like a real disaster that happened last year with Replit. Then we'll dive into dynamic authorization. So just kind of moving beyond the static RBAC to context-aware permissions that adapts throughout the agent lifecycle. And section 3 is the longest section, human in the loop. This is where most teams have issues, so we'll spend like a full 10 minutes on it. Section after that, of course, is about deployment patterns, a little bit of architectural examples that you can borrow, and a simple framework you can start using Monday if you wish. Does this sound good for you? Yeah? Excellent. So let's start with the why, because if you don't understand why this matters, none of the rest is going to stick. So let me tell you what actually happened at Replit in July of 2025. This is Jason Limkin's vibe coding experiment gone pretty wrong. If you look at step 3, there was an explicit code freeze, and the agent was told not to touch production, but when it saw empty query results, it panicked and it executed a drop database anyway. So there were 1,200 executives at that company. It was crazy. Like 1,190 companies that they had completely lost. And then it lied about being able to roll back the data. And this wasn't isolated. Throughout 2025, we saw similar authorization failures across the MCP ecosystem, and we'll touch on those in a little bit. All right, I think I got all right. So what I want you to take away from it, though, is that the problem isn't going away, and it's just going to continue to accelerate. But this wasn't really about AI misbehaving. This was about the architecture that created the ability for it to go wrong. 4 fundamental failures, and no environment separation, okay? There were no permission boundaries. There was no approval gates for destructive operations. The agent had permanent, unrestricted credentials to this, and no cryptographic session security at all. So the developer really never asked the most important question, which is, what is the absolute worst that agent could do if everything goes wrong? And it can't just be their opinion. This is where a team and different layers of people come in handy, because these are your perspectives of what could go wrong, but it's helpful to have someone else bounce that off. And in October of 2025, researchers discovered, I'm not going to name the entire code, but it was a prompt hijacking vulnerability where weak session IDs allowed attackers to inject malicious prompts into legitimate user sessions. And the November 2025 MCP spec update now requires cryptographically secure session IDs, but many implementations of what's rolled out there just haven't caught up. So let's start by getting the mental model right. What is the worst this can do? This sounds really simple, but if you formalize it as just part of your process and you put it in your documentation as this is the way we do things, it helps everybody in your company think the same. This was kind of scary when you think about it. There's so many attack surfaces now that we're not used to building for. So let's reframe this and stop thinking of agents as very smart API calls, although that was definitely what I heard within my own company. So start thinking of them as interns who have root access to your production systems. And they're very enthusiastic and they want to help, but they lack a lot of context. Yes? They lack common sense, and most importantly, they will execute what they think you meant, not what you actually meant. And unlike human interns, they never get tired, and they never hesitate, and they can work at scale for all day and all night. So would you give an actual intern unrestricted database access?
Yes.
Yeah, exactly. I got that within a year of being a developer. Anybody else? No. Hopefully, nowadays, we are gatekeeping this, yeah? A little bit? It's very, very annoying to have to restrict access because there's always something you need to do and you gotta wait and talk to some of the IT department or whatever. It's very annoying. It's a whole process that has nothing to do with whether or not your software even works, right? And that's why there's so much friction and people ignore it because it's like, I don't have time to debate back and forth with a security team, an IT team, an infrastructure team, the DevOps team. I don't have time for that. I just want to make sure this actually works all the way. The problem is that what you are testing for is a dream scenario that doesn't actually exist. I mean, I guess it does if your software only runs on your machine and only runs your stuff, but that's probably not what you're getting paid for. Yeah? Right. And yeah. According to McKinsey's 2024, I think, AI survey, 80% of companies already experienced unintended actions from some sort of AI agents, but at the same time, Gartner says 40% of enterprise apps will include AI agents by the end of 2026. Now, we all know to take everything Gartner says with a grain of salt. I love including them with my slides so I can look back later and think they were so wrong. But this time, I'm not so sure they're wrong. I think they'll have something somewhere, some sort of agent running, whether it's internal infrastructure or it's actually part of your production software for externally. You'll probably have something, even very small, that will be running. So today, it's 5%. Was by the end of 2025, they said 5% of enterprise apps. So they think in 1 year, 40% of them will include AI agents. That's insane. It's really good news for anybody who's doing consulting work, though, for sure. There's always like, okay, we put this thing, but now what? And here's the thing I want to make sure I'm very clear on. We are not unintelligent for not doing these things. Were you born coding? Because I certainly wasn't. And there are things that we do in our processes that we've had to learn by trial and error or by osmosis from some amazing, distinguished engineer. But a lot of those habits have nothing to do with this process, which means that you're not being dumb for not including these processes. That's why I have this talk. so that you can at least start somewhere. We're looking at an 8x increase in agentic deployment in 1 year, and it's possible. I don't know how well it will go, but it's possible that that is exactly what happens. So let's say that is the right thing to do for whatever you have at your company. The authorization patterns we build now will be running in nearly half of these things, right, by the end of the year. Okay. So before you write any agent code, you need to answer a few critical questions. What is the worst possible outcome of your blast radius? How many records will be affected? And critically, is the damage reversible? If you can't answer this, you are not ready to deploy. So, first one. Second one is identity. So, is the agent acting as itself with a service account? Or is it acting on behalf of a user? This matters because user-delegated agents should lose access like when the user logs out or their credentials expire. Service accounts don't do that. So you got to choose wisely. There's something else that I didn't write down, but it just occurred to me now, is that do you have a really good policy or process for when one of your developers leaves your team of how to revoke all the access to all the stuff you had before? You're going to have to do that for all of these things. Because what if you don't need that anymore, or you only needed it in one region? Say, we need an agent to run specifically to handle GDPR requests from the public. That's not something you might need in India, but you need here. So maybe you just revoke access just there. So that means that now your security team needs to also know about this, even if they're not the ones controlling it and it is the engineering team that is doing it. You have to have a policy on what it means to deactivate and activate service accounts, and also what happens when those credentials leak or they're not rotated or whatever. That is now a new process. To also add to this, agents are pretty cool and pretty powerful, but that means that they have to come with a little bit of a process. The other one is the life cycle. So how long should those credentials last? I always set mine to 365 days. How about you? No? No? Should they expire after 1 hour? Well, it depends. 1 day? Never? Spoiler alert, never is never the right answer. But it's possible that if you don't think about any part of this, that you may accidentally get yourself in a vulnerable situation, even though you've locked all the other gates, except for this one. So have a conversation with your team or with others who know what is probably doable for this. And you might have to do a lifecycle experiment to see what the real usage might be. For example, if you're running an agent that's specifically just for your own internal use as a company or as an individual, you may be very tempted to just leave it very long. And it's possible that that's the right answer to a point, but then you'll have to sandbox it and prove that that's the actual usage. You can't dream that it's the usage. You have to actually test it out. And oversight. So who gets to see what the agent is doing? How do you audit it later? When something goes wrong. And something will always go wrong. So if you just know that that's going to come, do you need to see it? Does someone else need to see it that's in a different team than you? Here's a big one. Does a third-party independent security consulting firm need to see it? Assume the worst. You have a huge breach, it's a big problem, and they hire a team to come in and do the post-mortem. That means you have to understand that you're going to need to set things up for that. I wouldn't just address it the day it happens. I would assume it will happen at some point and put that process in place. It's possible you already have a process like this, especially if you're in a regulated industry. You just have to know how to tie in what the agent is doing and what they are thinking. At the moment, what we are seeing in many instances is the agent thinking in English, but it's possible that that changes, and we don't see that. It's possible that, we're going to see a bunch of bash loops. It depends. So where are you going to audit it? Where is it going to live? If you answer these 4 questions, you're probably 75 to 80% of the way to safe agent architecture because you even thought about this in the first place. Notice I'm not saying a specific type of software you need to use. This is really just an approach. Okay. Who here is familiar with role-based access control? Most of you? A lot of my .NET people, yes. Okay. It's been the standard for decades, right? You just assign users to roles. Roles have permissions. Pretty simple. If a developer role lets you read a database and write to staging, but not write to production, seems like a good thing. But the problem is RBAC kind of fails for AI agents because it's too static. It can't adapt to context. So if your agent is doing a read operation at 2 p.m. on a Tuesday, it probably should not have the same permissions as the same agent doing a write operation at 2 a.m. on a Sunday, right? The time boxing is so much different. It's too coarse. It's like an all or nothing. You get the rights to do whatever you want on these features instead of in this time frame or in this particular context. Either you have access or you don't. So once an agent has permissions, basically it has them the whole time. And it has no approval gates. So everything is pre-authorized. There's no mechanism to say, this operation is so dangerous, a human needs to confirm it first, unless you build that by hand. Or use third-party software that does these kinds of things. So what I would say is that we need something better. Enter attribute-based access control. So instead of asking things like, what role does the agent have, we ask a much richer question. Who is making the request? Not just the agent identity, but also whose behalf is it even acting on? What resource is being accessed? Is it sensitive? Is it in production? When is this happening? Is it that 2 p.m. on a Sunday or 2 a.m. on a Sunday? When is this happening? Is it the first request today? Or is it the 100th request they've made this hour? Okay, where? And of course, why? What is the business justification? What is the risk score? Sorry. So if you look at this example, the agent might be able to delete records, but only if all 5 conditions are met, maybe. Acting on behalf of a verified user, the user has an admin attribute. Is it in staging environment? Is it during business hours? And it hasn't exceeded rate limits, then the risk score is probably below 70. Okay? This is what modern agent authorization looks like, at least what I've come across to work well. It's context aware and dynamic, and it's safe by default. Now let's talk about dynamic authorization. This is where we move beyond RBAC and ABAC. We'll walk through the complete agent lifecycle, so 5 stages from design to audit, and I'll show you how we build authorization that adapts to context. Because unfortunately, you can't just slap some OAuth on your agent and call it secure, although that is a good step. Here are the 5 stages every agent goes through. So stage 1 is design. Before you write the code, you map out capabilities. What can the agent do and what should it do? Then stage 2 is you authenticate. How does the agent prove who it is? Do you use a service account, use a delegation, or step up auth? Stage 3 is to authorize. So at runtime for this specific request, what permissions apply? 4 is execute, to manage tokens, sessions, and credential rotation, which everybody does, right? Good, we're all doing it. Audit, so now what happened? Who approved it? Can we replay it? Each stage has its own failure modes, and you need to master all 5. And if you get one wrong, then you will fail in production, then you know the answer here. So let's go through each one. The design phase is the most important exercise here, capability mapping. Sit down with your team and list every single action the agent might take for every API it might call, for every database it might touch down to the table. So for each action, ask 4 questions. Is it read-only or does it mutate the data? What resources does it touch? What is the worst case impact if it all goes wrong? And can you undo it? So look at this example. Are you searching documentation? That's pretty low risk. So you don't need a human approval here. There's no approval needed. If you're creating a draft email, medium risks, but maybe you decide, I still don't need any approval because I don't have access to a lot more. But sending the email, that's pretty high risk. Human approval required. Yes? Although, I've seen people live dangerously with this and just go for it. But that's not my idea of guiding us in the future we wish. If you delete records or modify payments, they are a critical risk, and you need a human approval plus a two-factor auth. This is, again, just a sample. So do this exercise before you write one line of code, because once the code is written, it's kind of too late to realize you gave the agent the keys to the kingdom. It's very tempting, though. Is it possible for us to even create this agent? Is very tempting, but you have to decide all this stuff first. And it's really painful. I spent 5 years doing a lot of work in the dev and security space, and the best advice I could give is to just start off with the security stuff all just set up, and then just go and write stuff. Because if you wait and try to push it in later, it's so messy. And it feels really annoying to set it up at first. But this is the way you have to think. The best part of this is you could think this way about your junior engineers, right? Your interns. It could be the same. What do they have access to and what are they allowed to do? You could do it even if you're not using AI agents right now, you could still do it with your team and start this process in general when it comes to capability. All right, stage 2 is authentication. How does your agent prove who it is? You have 3 patterns to choose from. The first one, of course, is a service account. The agent has its own identity, like agent 1, with long-lived credentials. This is good for background jobs and system integrations. Like cron jobs, you might want to keep going. The risk is permanent access. It's hard to revoke, and if those credentials leak, you're in trouble. The second pattern is user delegation. So the agent acts on behalf of the user using the user's OAuth token. It's pretty good for interactive agents where you want user-scoped actions. And what risk is here? The agent typically inherits all of the user's permissions. So if the user is an admin, or maybe you, the developer, then the agent is effectively an admin, right? Pattern 3 is step-up authentication. You can start with low privileges, and when the agent needs to do something really risky, it requires higher privileges, and the user has to re-authenticate. This is pretty great for mixed risk workflows. And the risk, of course, is more complex user experience, for sure, especially in a B2C application. So which pattern should you choose? Who believes it should be the service account? Who believes it should be user delegation? Who believes it's step-up authentication? The funny thing is that I've seen all 3, and there really isn't one that stands out. You just have to realize where you're at with this. When it came to my to-do list, you bet that was a service account. I don't want to think about it anymore. Like something that just captures my to-dos every day. The worst thing that happened is, it wrote too many to-dos, or it deleted the to-dos. But I can go back to the source of truth and write the to-dos myself. Like there was such low risk, and I didn't want to mess with it too much. But it was, again, one of those applications that didn't require too much thought. I'm assuming many of you work in industries that are much higher risk. Yes, especially like in the medical industry, or maybe in the aviation industry. There's a lot here. And it's possible to have different agents using different authentication measurements. Here's a fun diagram. I promise you I blew it up as big as I could. The key way OAuth 2.1 differs from the traditional OAuth is that instead of the user manually initiating the login flows, the AI model triggers the authentication flow when it needs to access the protected tools. So this is the one that we're looking at here in action. This is the OAuth 2.1 flow that MCP requires. All right, so step 1 is the agent tries to call a tool. It sends an email, create a calendar event, whatever. And then you get a 401 unauthorized with a www authenticate header. The header will tell the agent where to go for authorization. And that's RFC 9728. Yeah, protected resource metadata. That's just the first step. That's the second step. Step 3 to 4 is that discovery phase. So the client fetches metadata from the well-known endpoint. It finds out which authorization servers are trusted and what scopes are available. The agent discovers this at runtime and does not need to know in advance. That's very helpful. Step 5, OAuth starts. Client generates we call it PXE, and that's your cryptographic handshake that's preventing token theft, and opens your browser. A human needs to grant permission. We've seen this many times for lots of other kinds of apps. In fact, has anybody here actually used something like the Claude MCP server for web? Have you seen that work in action? If you haven't, it's really interesting. Look at it on like a sandbox computer that you don't need for other reasons, but it was interesting to watch it. I asked it to audit a website for me and tell me what it looks like and what things are missing, and that's exactly what it is. I granted it access maybe just for that time or forever, and that popped up, and then it was able to take control of my mouse and click around. That's kind of what we're talking about here. So you see that consent screen, send emails on your behalf or create calendar events, and you check the boxes, and you get to decide what the agent can do, not the agent or the developer who made it. You get to decide that. And then steps 7 through 8, the authorization server issues a single-use code that expires in 10 minutes, and client exchanges it for a token using that PXE verifier. This proves that the client is legitimate. And then step 9, the token is issued, and only the scopes that you approved are there. This particular one expires in 15 minutes and is short-lived by design. Every API call includes that token. The right scope, it can execute. The missing scope, then you get a 403 forbidden. You need more permissions, then the browser opens again. Again, this is going to be for an end user experience, right? There's no silent escalation. You have 3 security pillars here. You have PXE that prevents the token theft, and you have scoped tokens that limit what the agents can do, and short expiration limits the entire damage window, or again, that whole blast radius. This is the reason why, even though it is in its final stages, this was written out by the OAuth group specifically for the AI agent flow. Has anybody here actually used this flow before for your agents? Oh, good. They spent a long time figuring out what the right flow might be for this. And again, where do your agents live? What are they doing? This is just a B2C example of what that means. All right, stage 3 is where the magic happens, runtime authorization. And you need defense in depth, multiple layers. Layer 1 is the network. Can the agent even reach the resource? Or firewall rules like IP allow listing or VPC boundaries. It's the first line of defense, then the one that all of our DevOps people and security people love. Layer 2, of course, is authentication. That's usually where you come in. Is this really the agent that it says that it is? You have to validate the OAuth token, check the certificates, and then verify the identity. The next layer down is authorization. This is the big one, and for this particular request, at this particular time, does this agent have permission? You're checking OAuth scopes and evaluating ABAC policies and applying the context-aware rules to it. Layer 4 is data and application security. This is where I spend a lot of my time lately. Even if the agent has permission, you can limit what data is exposed to them. You can do row-level security, which restricts the rows a user can see. And column masking obscures sensitive fields as well. You can have query restrictions, preventing dangerous operations, and data encryption that protects information at rest and in transit, which you should be doing anyway, because all of you are excellent developers. And here's the critical part. This fails securely. If any layer denies the request, it just stops. You don't keep going. You don't give partial access. You stop. And this is how you would have prevented the Replit disaster. All right, stage 4, token management, session handling. How are we doing? Are we falling asleep? Staying awake? Okay. I know it's a lot of stuff to put on a screen, but I figured it was better to just kind of do little summary screens, just in case you want it later to refer to. All right, token management. This is where most teams get lazy, like me. And this is where things go wrong. You have to use short-lived tokens, and I'm very guilty of not doing that. Here's why. I will only do this when I'm in development. But that's a really bad habit, because then I forgot I did that, and then I pushed it to staging, and it's a whole problem. Your access token should expire in 1 to 15 minutes, and not hours, and not days. Minutes. Your refresh token, however, can last a bit longer, like maybe up to 24 hours. But after that, the agent needs to fully re-authenticate, I think, in this case. Why? Because it limits the blast radius. If a token gets stolen, the attacker only has a small window to use it before it doesn't work anymore, right? And look at the timeline. So look at the rotation strategy. At time 0, you issue a token with a 15-minute lifetime. At 14 minutes, the agent requests a refresh. At 14:30, you issue a new token and give the old one a 30-second grace period. At 15 minutes, the old token is fully revoked, and at 24 hours, the refresh token expires and you need a full reauth again. And you need session management. Track every active agent session, let admins view and revoke them anytime, and auto-revoke on suspicious activity, and log everything that happens. And please never store tokens in your code. We don't do that anymore, right? Okay. Never use tokens that never expire. We're not going to do that anymore, right? Right. And never skip encryptions for tokens at rest. Do not be that team. All right. Getting there. All right. Stage 5 is audit and observability. Because when something goes wrong, and it will, you need to know exactly what happened. And here's the JSON structure that I put up there for you. Log everything with structured data. Look at this example. You've got a timestamp, agent ID, user ID, the action taken, the resource accessed, the OAuth scope used, the result, who approved it, the risk score it has, and a correlation ID so you can trace the entire request chain. What should you track? Every authentication attempt, both successes and failures here. Every authorization decision, both allows and denies. Every API call that the agent makes, every approval gate that gets triggered, every error or exception, and every token issuance, refresh, and revocation. And you need metrics to monitor too. Monitoring the agent's request rate will help you detect anomalies when it's kind of going rogue. Track your permission denial rate to catch any misconfigurations you got there, and then count high-risk operations per hour. Measure time from request to approval. And so the goal is simple, right? 6 months from now, when someone asks, what did agent X do last Tuesday at 2 p.m., you can answer the question in 30 seconds. There are pieces of software out there you can use. There are lots of metric systems that can work. And I don't really care which one you use, or even if you build it yourself. Just know that these are the things you should track. With me? Okay. All right, let's talk about MCP, Model Context Protocol. It is an open standard for how AI agents access tools. It was published in November 2024 by Anthropic, and in December of 2025, they donated it to Linux Foundation's new Agentic AI Foundation. And OpenAI and Block joined as co-founders, along with AWS, Google, Microsoft, and Cloudflare supporting members, so lots of the big companies. So this isn't one company's side project. I'm sure you've heard some not great things about using MCP, but there's also some great things about it. At this point, it's kind of become a little bit of the industry standard of those who are messing around with agents here. There's over 97 million monthly downloads of this thing, and over 10,000 active servers as of the end of January 2026. So why does this matter to you? First, it mandates OAuth 2.1, which is a good thing, and doesn't allow any shortcuts there. Second, it forces explicit permission scopes like we talked about earlier. And third, it makes your audit trails possible. So look at this particular architecture. The agent never talks directly to the tools. Everything kind of goes through the MCP server. The MCP server handles the authentication, validates the scopes, enforces permissions, and then you kind of go from there to the tools. In this particular one, it could be your email, your database, your calendar, or whatever else you want to do. I'm going to leave that blank for you. So if you're building agents today and you're not thinking about how you would use MCP, then you're probably building a little bit of technical debt in there. Good? All right. Now we get to the most critical section, which is human in the loop. And this is where most of the teams that I talked to were having the biggest problem. They assume the agent can make a lot of decisions autonomously, and then the team across the road said, we want no autonomous decisions at all. Human in the loop for everything. For every PR, for everything that's happening, especially in production for our customers, we want humans the whole time. And that's really not what I'm here to debate with you. What I am here to debate with you is how do you think about it now? Is there an answer? Anybody who raised their hand earlier who has put things in production, have you figured out a good human in the loop process? Hopefully. I'd love to hear what you're doing whenever we're done here, because I'm always adding a list of use cases to my head. So let's look at the data, because numbers are sobering, right? 80% of companies have experienced unintended actions from those AI agents. 75% of security incidents involved excessive permissions. Like, I don't know, skip and run dangerous permissions. I can't remember the exact one, I'll have to go back. And agents that had more access than they should have. And while 66% of organizations now using agentic AI, only 52% can actually audit what the access is in real time. These other numbers come from IBM's 2025 cost of a data breach report at the end of the year. Shadow AI, which includes unauthorized agent deployments and poorly governed AI tools, creates breach costs nearly $700,000 US higher than traditional incidents. And they take longer to detect because the activity looks legit. It looks real. Those are crazy numbers. We're already behind just in the early days of agentic stuff. And here's the pattern that I'm seeing. Teams will launch with full autonomy sometimes. Not you, but like sometimes they will, and that's okay. Let the agent just do its thing is the statement. And then something breaks, and maybe a customer gets upset, or data gets deleted, and money gets transferred incorrectly. If you're an airline with a site and a chatbot, maybe it incorrectly told your customers what the refund policy was, and now you owe a lot of money to those people. Just a random example. So they scramble to add human approval gates, but by then the damage is already done. So you need to flip the script and start with the human side of it. Make the human approve every single high-risk decision, every single action. And as you gain confidence in your software with these guys, and as you see patterns, as your audit logs will show that the agent is behaving correctly, you can selectively remove the gates. But you start safe and not the other way around. I think when it comes to building our software internally, this is probably already happening. But knowing how that will work externally for your own software that your customers will use, that's the part that I think you just need to think about. So how do you decide when to require human approval? You need a risk scoring framework, and I use 4 dimensions here. Impact. So what is the severity of this action? If reading data is a low impact, like 1 to 3 points. Deleting data or moving money, that's a 10. It's a critical, right? So I'm going to assign it 10 points. This is fun for all my D&D friends. Okay, reversibility. Can you undo this? If yes, then it's a 0 risk. If it requires manual intervention, that's a -3. If it's permanent and can't be undone, that's like a -5, for example. In scope, how many records are affected? 1 record? Maybe that's a 0. 100 records? Maybe that's a -2. Thousands? That's like a -5. For context, when is this happening? Business hours? Then that's normal, because you're already at your desk and you're performing these actions, and this agent is acting on behalf of you, the developer, for example. During normal business hours, that's a 0. In the off hours, that's pretty suspicious, -2. Unusual frequency or failed prior attempts, -3 to -5, etc. And there's a formula up there if you're interested in it. Multiply the impact by reversibility, add scope and context. If your risk score is 70 or above, it requires human approval. If it's 90 or above, require human approval plus 2-factor auth. And this is how you can systematically protect your high-risk operations here. Has anybody else used kind of like a risk format, scoring format like this? Huh? Okay. Well, try it out and let me know. You can make up the numbers whatever you want, but this is just a good basic example here. So now let me show you how the approval gate decision works in practice. At the top is your action request. An agent says, I want to execute this tool with these parameters. We assess the risk by asking a series of questions. There's a 3 question boxes there. Is this action destructive, meaning does it involve delete, drop, or truncate? If yes, that's a +3. Does it affect more than 100 items? That's a bulk operation. If yes, +2 points. Is this happening in production? If yes, +2 points, etc. This keeps going down the line. Now we branch, then we add up all the applicable factors. That gives us our total risk score. And you can do that programmatically. Now we branch based on that score. So if your risk score is 0 or 1, then you auto approve. You can execute it immediately, just log it for audit, and no human intervention needed. This is your read operations, your low risk stuff. Most agent actions fall here. Then risk score 2 to 4, maybe they need asynchronous approval. We queue it for human review and maybe send a message in Slack, for example, and the agent can continue doing their other work. A human approves within an hour. This is a medium risk thing for like updating multiple records or issuing a refund. Risk score 5 or higher, maybe blocking approval. We stop everything and the agent just waits. We can show the human full context, what is being requested, why it's risky, etc. And then this is your high-risk operations like deleting production data, bulk operations, and prod and destructive actions. And remember, multiple risk factors can apply to a single action. So deleting 200 records in production, that's like destructive +3. And it affects more than 100 +2. And then you see, definitely blocking approval can very quickly get up. Your framework like this is simple enough to implement in like an afternoon or a couple of days, but it's powerful enough to protect at least and have a baseline of how to determine which parts of your features and your actions need to have guidance. There are a couple of real-world examples of what happens when the teams skip human approval gates. The GitHub MCP incident is particularly instructive because the attacker didn't need any credentials at all. They just created a public issue with a prompt injection payload, and the AI assistant read it, followed the hidden instructions, and exfiltrated data from private repos. Simple. The root cause was an overprivileged PAT combined with an untrusted content in the agent's context. That's the only one. The other ones are kind of interesting to me as well, so I threw them up there for you. All right, so now we've had a thought about how to score the risk. Let's go to deployment. So here's like the 5 things that I go through if you're going to deploy agents safely. This is what you're going to take home today. Step 1 is to start with least privilege and deny by default. Allow list only what you need and scope specific resources, not global access. This is your foundation here. Step 2 is to implement approval gates. We covered this in depth earlier, and keep humans as the ultimate arbiter just for your high-risk actions. Step 3 is to use modern authorization. As it becomes completely codified, OAuth 2.1 with scopes for MCP and ABAC for context-aware decisions are probably where you should start. And critically, use external policy engines and not hard-coded if-else statements here. I know it's easy to generate them, but it's better to use an external policy engine for that. Your authorization logic just needs to be maintainable here, especially if you do spec-driven development and you now have blown away your code. It's possible it gets reinterpreted differently the next time your code gets generated. So again, external, just try to design for that. Step 4 is to build observability in from day 1 and just have an audit trail for everything. Explainability for every decision and reversibility for when things go wrong. Step 5 is to separate your environments. Dev, staging, and production boundaries, we already do this. And just make sure it's automatic separation. Test in sandbox before you touch production, for example. So these 5 steps, that's the permission slip framework, if you will, that is a great place to get started. If you follow these, you'll build agents that are at least useful enough to deploy, but are constrained enough to trust. That's what I'm going for here. So before you deploy to production, you can go through a checklist that looks like this. I wouldn't skip one. I would go through each one. Does anybody here know what a circuit breaker is? Okay, a few of you. That means everyone else has no idea. You have to put circuit breakers in place, meaning that when something is going really wrong, the system shuts down. Famously, there's a circuit breaker on the New York Stock Exchange that whenever a whole bunch of selling is taking place and it goes over a certain threshold, they just stop the ability to trade, for example. And it can be the same for anything in your software environment as well. So make sure you do your architecture review to see if your compatibility map is complete and you've calculated your blast radius, etc. Please do not skip this. Do not tell yourself, we're going to add that later. Every single one of those items matter, and I'm sure you could probably add a few more, but this is, I would think, like the bare minimum. One missing checkbox is how you end up on the front page of Hacker News for all the wrong reasons. It's really boring, but you could probably get AI to help you even just check it off, right? Did I do everything? Can you check this with me? Yes? Obviously, you also need to have external people involved in this, but it gives you an idea. All right, let's make this concrete. Okay, a DevOps deployment agent there, in my second architectural example, is something that needs to access Azure Key Vault. I'm sure all of you have used that before. This example is based on your feedback for single-use, time-limited credentials. In the dev environment, the green, low-risk one, the agent requests Key Vault access. The MCP server issues a 15-minute token scoped to only that dev vault. The agent retrieves secrets and validates that the config is in dry run mode. After 15 minutes, the token expires and you're done. In staging, though, this is the yellow medium risk one, the agent requests a new token and does not reuse the dev token that you had in dev. The MCP server issues a new 15-minute token scoped to the staging vault itself. The agent deploys and runs tests, and the token expires after deployment. All the tests must pass before we move to production. In production, which is higher risk, everything changes. The agent requests a new token, but this time it requires manual approval to get it. A human approves with two-factor auth and provides justification. Only then does the MCP server issue that 5-minute token, which is shorter than dev or staging, scoped to the production vault. The agent deploys and monitors it for like 30 minutes, and if error rates exceed the threshold, automatically it rolls it back. Single-use tokens is the point of this architectural example. Each environment gets new credentials, and tokens expire after each use, and no credential reuse across environments. I mean, I have done that, but I don't do it anymore. This prevents a compromised dev token from accessing production or staging and messing any of it up. Environment separation through credential isolation. It rhymes. The final example is like a multi-agent kind of orchestration with permission hierarchy. At the top, you have an orchestrator. This agent has the narrowest permissions. All it can do is route and log and monitor. It coordinates work, but it doesn't execute dangerous operations itself. Below it has 3 specialized child agents. The analysis agent, which is pretty safe, has read-only access to the database and files, so there's no writes. The implementation agent can write to staging and read production, but it cannot write to production. And the deployment agent, which is orange and kind of gated, it can write to production, but every action is still gated and requires approval. This is one example. And notice the grandchild agent under analysis. This is the reporter agent, has even more restrictions on its permissions. It can only read specific tables, not the entire database, just specific ones, maybe even specific rows. Now here's what's pretty critical in the rules there. There isn't any permission inheritance, so each agent explicitly declares its own permissions, and child agents always have narrower permissions than their parent and never broader. So this is not like file system permissions where the child processes inherit everything from the parent. In agent orchestration, you explicitly scope every single agent. There is no inheritance and no surprises there. So this prevents permission sprawl and ensures that even if the orchestrator is compromised, the blast radius is still limited to its routing capabilities. Yes? All right. Here's your five-question framework. Before deploying any agents, answer these 5 questions. What's the worst that can happen? Who should the agent be? When do humans need to intervene? How will we know what happened? And how do we stop it if it goes wrong? If you can't answer all 5 questions, you're not ready to deploy. Full stop. This is just a quick way to, especially if you're a team lead, be able to verify with your teams, maybe at stand-up, where they're at with this. Here are a few resources for going deeper. Obviously, there's more things that have come out even since I originally wrote this talk. The Adversa AI MCP Security Top 25 is an excellent resource. It didn't make it on this list, but it catalogs the most critical MCP vulnerabilities with severity rankings and exactly how to mitigate all the strategies there. So you can treat it like OWASP Top 10, but for MCP. Although they also have one for AI. And pay attention to the November 2025 spec update because it added critical security requirements, including cryptographically secure session IDs. So look for that. Now remember, these are just examples and not complete endorsements. You have to kind of evaluate based on your stack and your needs, but some might be perfect for you. And some might not exist in a year. But you got to focus on just the pattern. Hopefully, this was helpful because I want to bring us back to where we started. Because this is not about you being paranoid about being able to deploy these guys. It's about being realistic. Agents will make mistakes, and they will misinterpret prompts, and they will hallucinate actions, and they'll overstep boundaries. And your job as an engineer is not to hope that it doesn't happen or just try to find a better model. Your job is to design systems that will handle it gracefully when it does, right? So now you have a framework, right? To do exactly that. You have dynamic permission scoping. You can be context aware for your authorization. You got human approval gates and a production deployment strategy. Everything you need to give AI agents their permission slips. So please tell me what you have built after this. And thank you all for being here.